Now, for our next example, we're going to be doing the second type of question, which is looking at inverse normal. So we're going to be using the other function on our calculators. So the example is, the probability of getting under a certain score is 84.1%. What is this score if the mean is 490 and the standard deviation is 90? Okay, so let's first understand what this question is asking us here. So I'm going to have a bell curve. I know what my mean is. My mean is 490. And I'm told the probability of getting under a certain score is 84.1%. Okay, under a certain score means that I'm going to have a bell curve and I'm interested in a certain score and everything below that score. So everything on the left side of that score. This is going to be 84%. So this blue is going to be 84%. Okay, so already I know that the value I'm looking for needs to be bigger than 490 because everything from the left to 490, that's 50% of our data, right? So remember, this 490 is the mean, median, and mode. So 50% of the data goes to 490. So my value I'm looking for, I'm going to call it x. I don't know what it is yet, but I know that this probability is going to be my 0.841. So I'm writing the probability as a percentage because in the calculator you're going to need to put the decimal value. Okay, let's see what we can do with our calculators. So we're going to go into, we're going to go into second function vars. We're going to go into inverse normal. Inverse normal is when we're looking for a certain value given a probability. The area, this is the probability. So the area is the probability. Our total area is 1, if you remember from our characteristics. So we need to input the percentage as a decimal, so 0.841. The mean, I was told, is 490, while the standard deviation is 90. Now, what does this mean? Tail, left, center, and right. In our case, we have a left tail. Why? Because we're highlighting all the part that's from the left to a certain value. In our next example, we're going to see what it looks like to have a center and a right tail. But for us, we're left because we're going from a value towards the left. So we're going to keep it as left, and we're going to go and paste this. And we get that our value is 580 if you round to 3 significant figures. So 580. Now let's think if this value makes sense for us. 580 is bigger than 490, so it does make sense for it to be on this side of our number line. So the number 580, that means we have 84.1% of people who are scoring 580 or less. Our next example, the chest measurement of 18-year-old male rugby players are normally distributed with a mean of 95 and a standard deviation of 8. From a group of 200 18-year-old male rugby players, how many would you expect to have a chest measurement between 87 and 111? So the first thing that we need to do is we need to find what is the probability of having between 87 and 101. So we're going to use our normal distribution for that. So what is the probability between 87 and 101? So if we're looking for probability, we are using our CDF, right? So we know how to do this. So we go into our calculator, second function vars, CDF. Our lower bound in this case is 87. Our upper bound is 111. My mean is 95, and I'm told that my standard deviation is 8. And I'm going to paste this. So the probability of having a male rugby player between 87 and 111 is 0.819 if we round to three significant figures. But the question asks from a group of 200 men. So we have 200 of these. Well, the probability of one of them being between 87 and 101 is going to be 0.819. So if we have 200 of them, then how many do we expect? Then here we're going to multiply our total number by our probability in order to get our expected amount of males who are going to be in this weight group. So we're going to have our 200 multiplied by our probability. You can simply go up, enter, and enter again. So we're going to get that we're estimating to have about 164 if we round to three significant figures. So out of the 200, we're expecting to have about 164 that are in this range. Our next question, B, find the value K such that approximately 16% of the chest measurements are above K. Okay, now for this one, above K, let's draw a little normal distribution to help us. So we have our normal distribution and we're told above K. So everything to the right of K has to be our 16% or 0.16. So since we're looking for a value given a probability, we're going to go into our calculator and do our inverse normal. Our area is our 0.16. Our mean is 95. And our standard deviation is 8. Now, left, center, or right. In this example, since we're going from a value towards the right, we're going to have what's called a right-tailed. So I'm going to click on right, and I'm going to paste this. So this value here is 103 if you round to three significant figures. Does this make sense in our question? 16%, yep, that should be to the right of 95, so 103 is correct. Our next example is a little bit more tedious in notation, so let's have a look. Given that x is normally distributed with a mean of 15 and a standard deviation of 3, find k such that the probability of x being less than k is equal to 0.2. Now, that means the probability that x is less than k. We're looking for a value of k such that it's less than. The reason why I put it on this side of the 15 is that this probability is 0.2. So we're not reaching the 50% mark yet. So we know that it's going to be on this one here. Okay, so for this question, we're given what the probability is, right? And we're looking for a value. So we're going to go into our calculator and we are going to use inverse normal. Inverse normal, my area is 0.2. My mean is 15. My standard deviation is going to be 3. And here I am doing a left tail because I'm going to the left of our number. And I'm going to get that this value of k is 12.5 rounded to three significant figures. The next example, find the probability that x is bigger than k is equal to 0.1. Okay, so 0.1 is our probability, and we're looking for something bigger. So that means we're going to be on this side of our 15, and bigger, this should be our 0.1. So we're going to go into our calculator. So we're going to go second function var. So we're looking for a number, so still inverse. So our probability is 0.1. We have the same mean, the same standard deviation. However, this time we're looking at a right tail, and we're going to paste it. And we get that the value of k in this case is 18.8, rounded to three significant figures. The next example is a little bit interesting. We have, what is the probability that x is between 15 minus k and 15 plus k? And it's equal to 0.9, and find k. So I have a certain amount. This amount is k. And I'm either subtracting or adding it to my mean. Now, the important thing to remember about this question is that our normal distribution is symmetrical. So since the center area is 0.9, one way that we can do this is, since there's equal parts on both sides, we can use our inverse normal, but center, because there's equal parts on both sides. So we go second function parts, inverse normal. We have an area of 0.9, a mean of 15, a standard deviation of 3, and we choose the center option, and then we paste. And you'll see that they give us two values in our calculator. The first value is 10.1, rounded to three significant figures, and so that's the value to the left of the 15. And the second value is our 19.3, which is the value to the right of our 15. So these are the two values that we're looking between. And then we can easily answer what is the k value, right? Remember, we're always looking for k. Well, k is going to be our 15, either minus 10.1, or we can have 19.3 minus 15. So when you do that, you're going to get your 15 minus 10.1. And you're going to get that the value of k in this case is 4.9. So we added 4.9 to 15, and then we subtracted 4.9. And our last example for today is very different from the others. The number of ASB students who go to McDonald's on Friday, X, is normally distributed with a mean mu. We don't know what the mean is, and a standard deviation of 1.3. It is known that the probability that x is bigger than 12 is equal to 0.23. Find the mean. So here we're slightly different. So let's first represent this on our bell curve. Probability that x is bigger than 12 is 0.23. So bigger than 12 will be somewhere here, because this probability is going to be 0.23. Now, this value is 12. So the probability that is bigger than 12 is 0.23. Now, in this situation, we're given both the probability and the value we're looking for. So we don't need to use inverse normal or CDF, but we do need to figure out what this mean is. Now, what we're going to be doing is we're going to be using our calculator, and we're going to ask it to solve an equation. When we ask our calculator to solve an equation, we're going to do what's called numeric solve. We use this only when we have one unknown, and most of the time there's only one possible solution. And let's see how we do this. In your calculator, you're going to go into math, and you're going to scroll up to the very bottom, which is numeric solve. In numeric solve, you're going to have two equations that are going to come up. You can delete whatever you already have in these two equations, so this is not relevant for us. Our first equation, our first part, is going to be 0.23. So 0.23 is equal to the probability that x is bigger than 12. Okay, well, let's go to the next one. How do I input here the probability that x is bigger than 12? So you're going to go into your second equation and you're going to go the second function distribution. And if we're wanting to get a probability answer, we need to use normal CDF. So probability answer, normal CDF. Well, the probability that x is bigger than 12, our lower bound is 12, and our upper bound is a really, really big number. So we have something like 10 to the power of 99. Always remember to close your brackets. Mean, we don't know what the mean is. So we're going to say that the mean is x, while our standard deviation is 1.3. And we're going to go ahead and paste this. So now we have our second function represents the probability that x is bigger than 12. And then we have that being equal to our 0.23. We're going to go ahead and ask the calculator to solve this. So right now our calculator is thinking, and there we go. We have our value for x. So this is going to be the mean of our distribution. So our mean is going to be rounding to three significant figures, 11.0. So we're going to have a mean of 11 for this question.